About a year ago, I finished writing my Telegram bot that could take speech and convert it into text from small videos or audio files, and I recently migrated that from running on the Pi 4 to running in a Docker container. The Docker container is built for ARM, ARM64, so Intel, as well as ARM32v7, which is the Pis. So can run on Windows, Mac, and Pis. And depending on the model size, you should be able to get good performance out of all of them. And it is a fun exercise. I have a chat here with it. So we'll start a chat. We'll have it activated. And now we will see how well the speech recognition works for a live demo. Being recorded and then hopefully not edited and played back. And so this is no longer running on a Pi 4, it's running in a Docker container that I built and ship with the tiny image, the small image, and the base image. Those are actually in the level that they perform. This is currently running the medium model. I'll take you through the repo, how it works, and what it does. We just have to wait uno momento. So the medium model is a bit slower than the others. Previously I was running smaller models for the Pi 4. The base model can respond in way faster than real time on the new computer here. It used to respond in about a minute for up to 20 seconds of text. And now it will be processing this message for us. Did I start the chat and then send the audio? Let us try one more time. Can you do text for speech for me on this, please? Thank you. So we'll wait for it to respond. Is it going to fail, as all live demos are prone to do? So I can see it has received the message and it should be processing shortly. We can go look at logs. So I can see I've started the chat. I've sent the messages. Are we having an admin in this group? Permissions, all administrators. Let us add our bot as an administrator. And we'll give that another go. Hello bot, are you ready to respond to my text requests? There we go. I can see it started processing. And this is the audio. Let's give that another go. Hello, are you ready to respond to my requests? Give that another go. Hello bot, are you ready to respond to my text requests? So it actually worked this time. That's wonderful. And so yeah, that's a quick demo of it, and it is mostly based on the amazing work of G. Gerganov, who did some amazing work on Whisper.cpp, porting OpenAI's Whisper model to C++, as well as building some example programs to show you how to use it. So let's go to a better view for seeing this window, and the bot is hosted at this on GitHub under TonyM128 Shhh Bot. You can see here, and I wanted to run through what the setup looks like. This will probably be a relatively short video. So it's the Shhh Bot, and it's this Telegram bot that can convert speech to text for small videos and audio files. It uses Docker, Telegram, Python, Whisper.cpp, and it stands up a small Telegram bot which you can run yourself on your own infrastructure if you'd like. And it's built for AMD64, ARM64, and ARM32v7. So Windows, Mac, and Pis. So you should still be able to run the new version on a Pi, which has some new features, which I think are pretty cool. One of the main ones is that it now supports a multitude of models. It's all in one Docker setup, so you can quickly stand up your own version by having a Docker compose or a Docker run. And it's able to cache the models between runs. So even for me personally, if I was still going to be running my service on a Pi, I would rather do it through this Docker container now, as it's a self-contained setup and it can be updated easily. So yeah, just to run through the setup we have here quick. The image is hosted on GitHub container repo under my repository, Shhh Bot. There's a couple versions that you can use. There's the standard one, which has the tiny image, so that's the smallest image that can do speech to text. It's also got the base image and the small image. There are a lot of other options. English only models, quantized 5.1 and quantized 5, all the way up to large v3. Large v3 5.0 is really interesting, as it's only a 1 gig file instead of the, I think, 4 gig file for the full v3 model, and it doesn't perform much better, but the size difference is really interesting and makes me think that there might be optimizations down the line which make this more performant, considering the size difference, having it in memory, maybe better bit operations that they can do on the CPU. So all of this is pretty much stock standard for getting something up and running. Two things to note, which I haven't actually mounted the volume in here. So we'd go volumes pretty much define. Yes, oh sorry, that is fine. This should be indented though, and it needs this inside. Why not? Let's just actually update our documentation live during the video. Bad documentation should not be allowed. So I believe this just needs to get indented one, and then this should have been indented another, and we'll just commit these changes straight into main. Mainlining. Okay, let's see if we got the updates we wanted. If my mice wheel starts working. Yes, so we have a models volume that I've mounted into models. You can do this volume however you want, map it to a local folder if you want, or just use Docker volumes. The thing about this is that it gives you the persistence of your models, which is now an optional config parameter. So you can change the Whisper model to any model you want out of these, and it will download it and run it for you. The reason I started off wanting to build the images with the model in the image, but I eventually moved away from that because I wasn't able to build the bigger images using GitHub's built-in build process, which I'm doing via Actions. So this repository takes your GitHub Actions and it builds the Docker file and it uploads it into the GitHub container repository. And probably for the larger models, I mean, if I'm building a lot of these, I'll save them some bandwidth. I'm thinking of removing the models and actually having it be download only during runtime. There's only one compulsory parameter or required parameter. It's the bot token that you get from Botfather when you chat to them. And this makes it your bot. So this is your API token. Don't share it with anyone. And that will be your bot running that you created and will be able to respond to messages. Everything else after this is optional. So the My Chat ID, you provide your chat ID and you'll get admin messages. And then for, it's just get this a bit more on screen. Oh, why does it have to be so far to the side? Then we have allowed chat IDs. And you can provide any chat IDs. So this is an allow list. It allows you to specify the only people who are allowed to use the service. So if you want it to only be for yourself, you can do that. You can also add group chats in here if you want. So my example is actually a group chat that I'm running. And that group chat has a negative number. It's kind of how you identify it. In this case, mine starts with a -100. It's also a longer number than the general user numbers, but it is supported and it does work in the allow list. We mentioned the model, and you can specify whichever model you want, and at service startup you'll see that it brings in the model, and thanks to a lovely Reddit post I did, I got some feedback that there was someone using it for different language and they would like to get their responses in that language. So when you run the Whisper main file, by default it actually responds in English, and it just tells you it's a foreign language if it's in a smaller model, but the bigger models will be able to convert it to English and then send you the text for that. But if you provide some additional parameters to Whisper, you can get it to respond in the language. So in this example, -L, I'm telling it the language is Netherlands or Dutch, and it will respond in actual Dutch with the properly converted text. I mentioned the volume mount, so all the images do come with a model. The main repo Shhh Bot image comes with the smallest tiny model built into it, so it can run without that, without having to download anything, and you've got 3 options for that. But if you'd like a bigger model, just download this one and specify the Whisper model in your config. For the Whisper options, there are a lot of command line options. I am using the output text so that we have a text file output when we run Whisper, and I think that might be it. And so it's just the text output. It basically strips everything else off, but you can specify any of the other options you wanted. If you want to enable tiny diarise, you could do that. You just change your option to -TDRZ, and then make sure you're using a TDRZ model. There we go. Or any of these other options. If you wanted to do translation, if you wanted to auto-detect the language, it defaults to English. Yeah, I mean, you could really break things with this, but that's an open option by default. It won't do anything, and you'll be able to use the service without changing any of these options. But if your use case differs, feel free to pass in the Whisper options that you'd like it to work with. Oh, -F, just to specify the file. So OTXT, I wouldn't change the output format unless you're going to change the code, and then -F, and your supplied commands will be run in between there. And that pretty much covers the basics of the bot. I thought we could take a quick look through the code. It's had a pretty major refactor since I worked on it last. Let's just get this window resized in. There we go. So I am running the script. So let's start with the Docker file. It's probably where most of the effort has gone in. So we have the Python builder image here. It downloads the source code for Whisper at the current version, and then it builds it so that I get the executables, and then it uses that builder to pull the executable across. I call it Whisper when it's pulled across, but it's the main file that's built in the example. I copy the models downloader over from the repo, and then I actually download the model that I've specified either over here or via a build argument. So you can specify build arg in whatever model you want, and it'll overwrite the tiny, but if you don't specify it, then the tiny model will be brought through. I had a lot of fun trying to work out why the script wasn't running. It's because it was getting copied over with a crlf instead of just lf, so I could have maybe worked that out on the GitHub repo, but I actually just DOS to Unix and done is done. And then I run the downloader for the model. I didn't want to edit any of the source code for anything really. Whisper is its own standalone project and it's amazing. So I'm trying to leverage what's in place there, and if it changes, I'll be able to pull the changes without having to run some weird sed scripts or anything to update it. So this downloads the model into the folder that it's in. So I've put this in the models folder, and I say download the model, and it downloads the model. And then just initially, the way the code was set up, it looks for the model inside of the user local source models directory, which is where Whisper is. It's just default setup. I left as much as I could default, and it just creates a symlink from the model that you've downloaded to where all my code expects the model to be. Other interesting things, we need ffmpeg and wget to be able to download the model, so all of these tools get installed, and this is the image. So it's basically Python Alpine, and it's got a couple extra things in it just to facilitate running Python and the scripts. There's two scripts. The one is the downloader, and so the downloader will download whatever Whisper model you've specified, and it checks to see if the model exists. If it doesn't exist, it'll run the script to download it. And the reason there's a copy in here is that I take the model from our source directory and I put it into the model's volume so that we can download the model into the model's volume that we've mounted. Then we're running the download as per normal. It'll download the file with the name of the model that you're downloading. And then if the model isn't the same as the currently linked model, we'll just link this model there. So this is how you can hot swap your models, just by relinking to the user local source models ggml model.bin symlink. So if you change your models and restart, you should have your existing models in the folder. It'll test to see if they're there. If it exists, it'll just symlink the model that you want to the symlink that all the scripts expect. So yeah, relatively straightforward, but you will not believe how much I struggled with it. We've also got the convert script. So it runs ffmpeg to convert whatever you've sent through into a WAV file that gets accepted by Whisper. And then it will run Whisper using those Whisper options if you supplied them. And here is the text file we're using for output, and then I've specified the model over here and the WAV file that it's going to be decompressing. So these are helper scripts. It kind of facilitates running Whisper easier, helped with development just to have these simple scripts that I could pass parameters to and have it run, kind of isolated the functionality from the code. Inside of our Python program, it's not too many pages. Yeah. Let's see if we can get more of it on page. Come on. So we have our Telegram bot that we've imported. Everything else is pretty stock. So we've got some logging, and we've got sub-processes for running the bash scripts. And I struggled quite a bit getting the allow list to work. I'll explain that in a bit when I get to it. But I ended up adding a couple unit tests just to test that. And it just ended up easier putting all of this into a class I've got all the options as part of the class, and once we've set those, they'll be used throughout the program. The Telegram logger was quite verbose, so I've just set it to warnings only, just to keep the logging down inside the bot to a minimum. And then we've got the start bot, so this just checks that you've configured what you need to. Outputs a bit of the configuration. It doesn't output your API key into the logs, but it does put the chat IDs, the Whisper model, and the options that you've specified into the log. If you've specified the Whisper model, it'll run the download script, and the download script won't download anything if you already have the model, and I'll set up the symlink so that it can run it. After that, we're just getting a Telegram bot up and running. We set the handlers for starting a conversation as well as messaging. We've got an unknown handler and we've got the actual message handler. And these are just boilerplate code just for setting up what it can handle and how it can handle it. Bot await messages. If anything goes wrong, you'll get an error message and it'll exit. Otherwise, it's going to be running polling until you exit the app. Some helper methods. So this is the check user. If you've set the allow list, it'll run through here and just make sure that the chat ID that is currently or that you've specified, which is the current chat ID, is in the allowed list string that you provided. If not, you'll get a logged message for it. If it goes through, then no messages, it'll just start processing. When we start a chat with the bot, it will run this code just to tell you that it's now authorized to talk to you. It cannot do anything with your user until you've actually allowed it to. And then unknown messages, or unknown, if it's unable to process what you've sent, it will say so. For handling the messages, so we'll check if we've defined our user or not, then we'll start processing for them. This will get sent to the admin if it's defined. It also does get sent to the logs. And first thing we do, we get the file. Just going to check that the file's under 50 megs. I could remove this now, but it made sense for the Raspberry Pi 4. I kind of say short, but at almost 11 minutes long, I think we're, quite long messages that it can process. And once it passes those two checks, we'll move on to the download and process. So we're downloading to the temp folder, and from the temp folder, we're just processing the file that we've downloaded. So we run the convert script. We output standard error and standard info into the convert log. So if anything goes wrong with FFmpeg converting the file, or with Whisper, the main program converting a speech to text, it'll let you know. We have an expectation of getting the text in wav.txt with the file name that we got from the source file. And when we're done, we'll just delete and clean up everything. It does have a DBM file store. Could remove this, but it just stores username and messages, amount of messages. So if it finds the username, it just increments the amount of messages we've processed for them by 1. It's not super useful. It's a tiny bit of logging. If there's a lot of desire for it, we can add some sort of admin onto the project, potentially even a UI to update the lists and admin IDs options, and then just add a bit of restart logic around that to be able to work with that. This possibility could update the model while the application's running, because Whisper will only run when you receive messages. We could take the bot down, change the model, bring the bot back up, and the same for any of the other options that are in there. If we get any exceptions, we're going to go take a look at the log and send it back to the user, well, send it back to the admin and send it to our log file so we can see what went wrong. And we'll also tell the user that there was a failure processing their message. And then the main. This actually just runs the bot. So yeah, that was a quick overview of the code. It's not too complicated. I kind of worked through all of this on my own. It was interesting coming back to it and finding that I was able to just hack it to what I want. There's not that many lines that I was worried about, and the complicated things to work out initially were getting the conversion correct using FFmpeg and sending it to Whisper, which feels like, yeah, pretty done at this point. Then I did mention the workflows, actions that we have. So this is an interesting action. This is the Docker tiny build, which is the one that you'll find on the main repository. So on a push to the main branch, we'll build it, and if we get a version tag, we'll build it. If we get a pull request to main, we will build it. And this is cool just for seeing that everything works. We're going to use the GitHub container registry. The image name's going to come from my repo. You'll see in the other ones they're pretty similar, but I've just changed the additional name there. So when I tag latest in this image name repository, it will be the small latest, and you'll get the 3 images together. So if you try to grab from the Shhh Bot main repo, you will get the MAM file. So that's a Docker file that contains all the Docker files. You don't have to worry about which architecture you're on. As long as I've built for it, it will grab that for you. So this was pretty much copy paste from GitHub setup. Running on Ubuntu. I'm gonna check out my repository. I'm gonna sign the store. I had some issues getting this up and running initially, but for some reason, once I started checking that it was working, it started working. So now it cosigns these, so you can know that I was the person who uploaded the image and signed it, and it's related to my build on the repo. So if you trust me, you can trust my images. Or just clone it and build your own, and that's fine. You can sign them too. Once we got that, we got build kit that we pull across. Oh, that was the issue. The cosign that was pulled through on the scripts that they hadn't been updated to the latest version yet. So once I updated the version, it started working. I told it to check. I left the check install in anyway. So using Docker build X, instead of just building for the architecture one, we can build for any architectures that are supported by this. And this is all boilerplate. Get into the registry that I'm going to be uploading to, get some metadata for the image, and then we've got the build and push action. And so I defined the platforms that I wanted to build for here, and then we're going to sign the image that's now been uploaded, and that's pretty much it. So we have our repository that I'll show one more time. And if I go to the main repo page, we can see our actions that have taken place on the builds. And you can see the latest version I pushed was, let's go with small. This one would have been the last build. It's fine, whichever. 43 seconds, that's not the one I wanted. The other builds, yeah, I get the Intel builds really quickly, and then the others take quite a while. So here we have the main build for the base image, and you can see it goes through all the steps. The interesting bit to look at is usually build and push the Docker image. And you can see it starts off a whole bunch of different steps to create the images. It's installing everything I asked for, and you can see here it's downloading the model. I'm so torn. I don't know whether it's more worthwhile to not have any images with the model, but then you won't be able to run this without an internet connection, which I thought might be useful to some people who wanted to not have it reach out to the internet and pull a lot of data. You just actually run the model as it comes through. And so base models through, and we're installing the pip requirements. I believe my code runs pretty soon. So we're just copying over the Python script, the convert script. We are cloning. You see sometimes, so depending on the stage it's in, so stage 1 is my image that I'm building, but yes, the builder is actually still busy. So it works out what it can do in parallel, which is quite nice. And if we go look at this again, yeah. So you'll see inside our Docker file, we've got the builder image. So I don't really want to have all of these dependencies installed, and I don't want the whole repository, but I do want to build it. So once I've built it, I just copy over the files I'm interested in, which makes us have a smaller image. So I haven't installed git, make, g++, vim, or wget. Well, wget is here, but I haven't got git and make and g++. So it ends up being a smaller image for the things that I've excluded after building the binary that I wanted. So you can see here it's busy making the repository. It's cloned and make, cloned and make. And finally, once we've run it, we'll see here, so just copies the scripts over, and finally we'll set the entry point just before it pushes the image. And then so once we've got our exported images, they're pushed. And what's quite cool is I don't actually need a dev machine anymore for this, because from the code I can actually open up a code space in my browser even, and so now this is a browser code editor. It's going to connect to the repository as me, and in a moment, I love when computers go so fast. So in my web browser, so I've used, I think it's vscode.dev, and then you point it at your GitHub repo. This is kind of the next level where it's actually creating a connection to a code space server that will be able to support like a terminal and running commands and editing the code. So I did most of my code editing in one of these just because it was easier to be able to edit the code. I didn't have to worry about building, because the second I commit the code, it'll get built in main for the one script, and I can run the Docker image from main. And then when I tag the branch for a release, it will get built for all the different versions of those images that I built. Interestingly, if I wanted to change my build script, then it might be interesting to have just a build pipeline for main that only builds the Intel ARMD64 build, which builds faster than all of the others. And then for my full release, I could build the others as well. Optimization I haven't done. I think we have a problem with being busy hours, possibly. Every time I've run this, it's gone a lot faster. But maybe we can take a look at what's going on here. Maybe it would like me to delete my current code space. Come on. So it is connecting to that one. Let's start another one. Use all the Microsoft servers. Maybe it's not that great using this during US business hours. Oh, okay, new bot's coming through for me better. I think my other one was a little stuck. So yeah, you can see I was using visual code earlier. Possibly the biggest difference is that I'm not in dark mode at the moment. There we go. Eyes aren't bleeding anymore. So yeah, you can see we've got pretty much that same interface that I was showing earlier. This is Visual Studio Code in a browser. Pretty much most of the things are working. You can install a lot of the extensions. So there we've got GitHub Actions. I'm not going to sign in right now. You can view all our models, and all the files should come through with their scripts. And if I want to run anything here, I should be able to. And yes, my bash script did not work very well, but it did do what it was meant to do, and outputted what it was meant to output. But I should be able to run my tests here, all 5 of them. So there we go, running my tests. Should make this part of the build process as well, but it's fine. And that is a overview. Top to bottom, let's see if my bot is still running at the end of the demo, which I feel quite certain it should be. Let's give that a go. I got my processing message, and we should have text shortly. Thank you for that loud beep. My bot is still running at the end of the demo, which I feel quite certain it should be. Let's give that a go. Awesome. I hope you had fun watching this. If there's any features you think you want on this, go take a look at the Shhh Bot repository. Feel free to log issues, pull requests, or anything that's interesting to you. I'd love to hear about it. Thanks for watching. Cheers.